Hello everyone, welcome to Engineering Archives. Let's look at our second problem for this chapter. So the question says, resolve F2 into its components along the U and V axes and determine the magnitude of these components. Resolve F1 along the U and V axes and determine its components. Find the magnitude and direction of the resultant force from the positive U axis. So basically we have to resolve both the F1 and the F2 forces along the U and V axes, and then we have to find the resultant force and find its direction from the positive U axis. So let's start by drawing the axes and how they would look like, just to make it easier for us to visualize the vector triangles. So the V axis is completely vertical like this, while the U axis is a little bit slanted. And the angle between the U and V axis in this quadrant is 105 degrees, while in these quadrants the angle is 75 degrees. Force F2 looks like this, while the force F1 looks like this. This angle is 30 degrees, and this angle is also 30 degrees. So let's start with the force F2 first. We know that the vector for F2 should be something like this in this direction. And we know that its components have to be in the direction of the V and U axis. So what if its component along the V axis is like this? And what if its component along the U axis is like this? So this is F2U, while this is F2V. We know this angle from the question, which is equal to 30 degrees. We can find this angle by looking at the diagram. This is the angle between the force F2 and its component along the V axis. So the angle between the force F2 and the V axis. In other words, this angle right here. This angle is the difference of 105 degrees and 30 degrees, and so this angle would be equal to 75 degrees. We can find this last angle by subtracting 75 and 30 degrees from 180, and the answer that we get is 75 degrees. Now that we have all our angles and we have the length of one side, which is the resultant side, F2 equals to 150 newtons. We can simply apply the sine rule and find the length of the other two sides. According to the sine rule, F2V over sine 30 degrees should be equal to 150 over sine of 75, and we get the value of F2V equals to 77.65 meters. Similarly, applying this sine rule for the other component, we get F2U over sine of 75 should be equal to 150 over sine of 75. Sine of 75 cancel each other out, so we get F2U equals to 150 degrees. Let's Do the same procedure for the other force, which is F1. So let's do F1 right here. So the first vector that we can draw is the vector for F1. It should be in this direction. Its component along the u-axis is like this, while its component along the v-axis is like this. We know this angle from the diagram, which is 30 degrees. We can find this angle as this is the angle between the force F1 and the v-axis. In other words, this angle right here. And this angle is the difference of 30 and 75 degrees. So the answer that we get is 45 degrees. We can find this last angle by subtracting 30 and 45 from 180 degrees. So we get 105 degrees. Now that we have the length for one side and all the angles in the triangle, we can simply apply the sine rule to get the value for the components. So according to the sine rule, F1 u divided by sine of 45 degrees should be equal to 250 over sine of 105 degrees. F1 u is equal to 183.01 degrees. Similarly, for the other component, F1b over sine of 30 degrees should be equal to 250 over sine of 130 degrees, and we get F1b equals to 129.4 degrees. So before we move on to find the magnitude of the resultant force and its angle from the positive u-axis, we should first draw the directions. This is a step that we should have done in the beginning, but since I forgot, I'm going to do it now. So the direction for the axes that they have given us, we can take either side to be positive or negative. So I'm going to use the conventional method and put my positive and negatives on the axes. So according to this convention, the value for F2u should be negative, since it's in the negative u direction. Now moving on to find the magnitude of the resultant force. We can find the magnitude of the resultant force by summing the components along the u-axis and the components along the v-axis. Let's sum the components along the u-axis. For both forces. So F1u plus F2u should be equal to 183.01 minus 150 degrees, and this should give us 33.01 newtons. Now summing the components along the v-axis, will give us F1v plus F2v, and this should equal 77.65 newtons plus 129.4 newtons. This gives us 207.06. Now to find the resultant, we can't use the resultant formula that we used for axes that were perpendicular, since these axes are not perpendicular. So we are again going to use the vector triangle to add these two components, resultant components, for the resultant force. So the component along the u-axis would be like this, while the component along the v-axis would be like this. And the resultant would be like this. We know the angle between the u and v axes in this quadrant, and this angle is 105 degrees. So now that we know lengths of two sides of our triangles, and we know the angle in between, we can apply the Cauchy rule to find the length of the opposite side to the angle, which is this side, to get the values for the resultant. If you don't know what the cosine rule is, you should Google it up. But according to the cosine rule, r should be equal to under root 207.06 whole squared plus 33.01 whole squared minus 2 times 33.01 times 207.06 times cosine of 105. So this is all under the under root. So the answer that we get for the resultant is 217.95 newtons. Lastly, to get the direction, we can simply apply the sine rule to get this angle theta, since this is the angle between the positive u-axis and the resultant vector r. So applying the sine rule to get the value of theta, according to the sine rule, the resultant, or 217.95 newtons, divided by sine of 105 degrees, should be equal to 207.06 divided by sine of theta. And once we solve for theta, we get theta should be equal to 66.6 degrees. So this was the simple but lengthy procedure for this question. We applied the triangle, we drew the vector triangle 3 times, and we also summed the forces, the two forces, by summing their components, and then by drawing the vector triangle one last time to get the resultant, and also to find the angle. Thank you very much. See you in the next practice problem.